Okay, let's do another problem. Satellite problem. These are fun. We have the Earth. This is the Earth at the center. And we have some satellite going around orbiting planet Earth in a circular path. And we want to know the altitude, or how high is the satellite above the surface of the Earth. So what we want to know is this height here, h, from the surface of the Earth to the height of the satellite. Well, we're given, in this problem, we're given our centripetal acceleration is 8.89 meters per second squared, and we are given the tangential velocity is 7.76 times 10 to the third meters per second. So we want to find the altitude. What we want to do is go back to our equation for force. The centripetal force is mass times the centripetal acceleration. The centripetal acceleration then is Vt squared over r. Now that r is the distance from the center of the object, center, remember, because it's moving in a circle, so it's from the center to where it is. That is this length here. This is the r in my equation over here. But now look, this r is the radius of the Earth plus the height above the Earth. So if I solve for r first, which I can do because I have 8.89, that's the centripetal acceleration. Vt I'm given, and remember to square this whole thing. That's going to be over r. Now I have to find r. So I do a little bit of algebra. I could cross multiply and then divide by r. And this is something that you should know how to do. But before I do that, let's just take it one other step. Let's say it's 8.89 times r. I'll multiply both sides by r. See, if I multiply this side by r and this side by r, then on this side the r's will cancel. And I'm going to get this. Now what I'm going to do here is square this first term. And now if I have a power raised to a power, this here is going to be 10 to the sixth. Okay? And why is that? Well, if I show you why, it's because you have this. Third times, now we're going to do it again because the whole thing you see is squared. So these two guys is this, and the whole thing is going to be times these two. And if you say 10 to the third times 10 to the third, that's 10 to the sixth, because you add the exponents if you multiply two powers. Okay, so that's what we get. And now in order to find r, we're going to take this whole thing and divide by 8.89. And if we do that on a calculator, I've got that r is going to be 6.77 times 10 to the sixth meters. But now remember, they didn't ask for r, they asked for h, the altitude, up here. So r, let's put it here, is the radius of the Earth plus the altitude h. All right, that's what we said. This is the distance here, r, the radius of the Earth plus h. So h then will be this r minus the radius of the Earth. So this r that we calculated was, so h then is going to be what we said, 6.77 minus the radius of the Earth, which I didn't give you, but the radius of the Earth happens to be 6.38 times 10 to the 6. So if I subtract these two numbers here, I come out with a height of 3.9 times 10 to the 5th meters, which is 3, 9, 1, 2, 3, 4, right? So that's in meters, so that's 390 kilometers. That's how high the satellite was. And not really that hard. Just have to use this formula here. You're given the acceleration, you're given the tangential velocity, you then find r. Once you find r, you notice that this r is center Earth to the satellite. What you want is the height. So the height plus the radius is going to give you r. Where is it? So r is the radius of the Earth plus the height. The height then you get by taking this distance r minus the radius of the Earth. And I should have put it up here, but the radius of the Earth was this 6.38 times 10 to the 6 meters. Okay? So that's about it, and wish you guys luck, and we'll see you soon.